Greenland's not melting as it has been over the last few years either. It's actually gained 550 billion tons of new ice.
Adapt 2030 Mini Ice Age Conversations covers changes in our climate due to a new and intensifying grand solar minimum. In the media, overlooking, downplaying, or burying cold weather changes occurring on our planet. This is in order to keep the global warming agenda steaming full speed ahead. I do this podcast and radio program because we need to begin conversations on how to adapt our food growing strategies long before 2030 as agricultural zones shift, affecting global crop output, but very few mainstream media outlets are talking about the most important issue of our time, cold weather crop losses. Our sun is going through a 400-year cycle, which has effects on our weather patterns as our magnetosphere weakens and the jet streams go out of flow. It's not CO2, it's not you, it's the sun. Are you ready to thrive in the grand solar minimum? Then join me for Mini Ice Age Conversations. I'm your host, David Dubine.
Like just the shorebirds alone, you got to think about these migrating Arctic birds. So they stop on the western shore of Greenland. Now, at least since researchers, and at least since the early 70s when people have been following these birds, they fly over in the western part of Greenland and they land, and there's usually some sort of grasses. It's pretty barren, but there's some grasses coming up that they're able to, A, find food, B, get some nesting material, and for the last 45 years, they've always had a place to come and land and breed and nest. Now, this year, there's nowhere for them to nest, and they're starving to death. Now, this is a cold weather event, so not much of the media wants to pick up on this one. But I assure you, I promise you, 1,000%, if this was due to too much heat and the grass was parched and baked and it just didn't grow because of the heat, this would have been followed from day one, the saga of the migrating Arctic shorebirds. That would still be a thing like the pelicans stuck in the oil in Iraq or something like this. Remember that? People followed the pelicans stuck in the Iraqi oil after Saddam, took the wells and just opened them up, caught them all on fire. All the birds are trapped in there, and everybody's. How about the Exxon Valdez? How long did we see the little pictures of the birds? How about the blowout in the Gulf of Mexico? BP oil spill down there. Images after birds. Terrible disaster of oil, etc. We followed that story for weeks and weeks and weeks. Now we got birds starving to death. It's an extinction level event for these couple species up there that are needing to nest. They'll fly back themselves, the adults, but there'll be no new young this year. And if they're not eating and feeding themselves, how are they going to get back up? They're supposed to fill up and be plump when they go back up. So nobody wants to cover this story except independent news media outlets. So here's another one. I found this one incredibly interesting. This is off Big Wobble. Big Wobble's pretty pro CO2. They have a lot of articles on there. Good rundown, though. They have a lot of stuff on volcanoes. If you are really looking for information on volcanoes, collapsing dams, this kind of stuff, they have a really good rundown on natural disasters coming out of California. Here's the headline. This comes off of First Alert, Channel 4 News. The humidity is just horrid. 5-year drought and extremely warm ocean temperatures. Okay, wait a second. Stop for a second. 5-year drought. Are you kidding me? That last year they had all-time record snowpack, record rains, floods. That in itself, with a simple search on any search engine for record snowpack and record rain in California with massive, massive flooding with all those arc storms that came through last year. 5-year drought? I want to smoke what they're smoking. Because whatever they're smoking is way better. To be talking about a 5-year drought after they had 2 years of record rain, what kind of alternative dimension are you guys in over there? Extremely warm ocean temperatures. And I said ocean temperatures, this is super easy. Up to the minute, sea surface temperature analysis, sea surface temperature anomalies, weekly change, global temperatures, regional temperatures broken down. So here's where I want you to go interactive. If you go up to this website called tropicaltidbits.com, I'll even spell it for you in case you're on the net and you want to take a look at some of the images I'm going to talk about. So it's tropical, tropical, and then it's followed by the next part there, tidbits, tidbits.com. So what you want to do is when you're on the top browser bar, you want to go over to where it says Analysis Tools. It's the fifth one over, 1, 2, 3, 4, fifth one over on the very top there. It says Analysis Tools. And it'll be a drop-down menu, and you want to come into Sea Surface Temperatures or Ocean Analysis. Now what this does is it opens up a whole different page with 5 different data sets of, I'll read them through. One is just sea surface temperatures of the current sea surface temperatures registered every 3 hours off the network of buoys across the planet. This also takes into consideration ship reports that are reporting as they're transiting from point A to point B. That is not the same every day because, of course, there's not a static amount of ships that's moving at a certain one time throughout the oceans. But in the logs, when they report, they take those temperature marks from ships that are traveling, as well as all the stationary ocean buoys, and they're mixing in a bit of satellite temperature data inside there to get a composite mix of all the sea surface temperatures. Now you'll notice if you're with me on there, if you click the drop-down bar on any of these maps, it'll show you by region. You can start off by the world, and it's a flat map, so it's not a circular one, it's a flat one, it's very easy to see. And then we get broken down into North Atlantic, Western Atlantic, Tropical Atlantic, that's the equatorial band like Caribbean and South, Western Pacific, Central Pacific, and then Southwest Pacific. So that covers everything from Asia to North America up there, and also Australia. Australia itself has its own Indian Ocean, that's the Indian Ocean dipole, and then we have the South Atlantic. All right, so these are the regions that are covered in the temperature charts just for sea surface temperatures. Now the drop-down bar is exactly the same for all the other data sets. So we have sea surface temperature anomalies. So what it does, it will show you, compared to the 30-year average, the temperature right now is what? So today's temperature compared to the last 30 years. Is it even? Is it above? Is it below? And again, you can break it down by region so cleanly so you can zoom in on a region of the map. Then there's a sea surface anomaly 7-day change, which shows you over the last 7 days, how did the temperature in the water move? Did it increase in temperature over the last week? Did it decrease? And then there's a couple other data sets down here. Also, another one I like is the Sea Surface Anomaly Time Series, which is a graph literally showing you the different regions around from the El Nino regions, which extend off of course, the equatorial going into the Pacific. They have all the regions covered, El Nino 3.4, Nino 3, Nino 4, Nino 1 and 2, closer into over South America there. And again, as it's all the same things, North Atlantic, mid-latitude Atlantic, multi-decadal oscillation, Caribbean, global, South Tropical Atlantic, Gulf of Mexico. This is the only chart that has Gulf of Mexico in there. It's actually a dotted chart, so it'll show you the 0 line, and then it just shows you the temperature in a blue line. Where was it? And even in the article, they don't put anything about, hey, go check out the sea surface temperatures. They don't put any links to any of these. There was an article released from Harvard telling you that the deeper oceans have all cooled, not warmed. Harvard released a peer-reviewed study showing that all the deeper water temperatures have cooled by 0.2 of a degree at least across, that's an average on our planet. There were other areas that were much cooler, like 1.2 degrees Celsius drop, etc. But see what I mean? In these same articles, like everywhere you go, you can come and find an alternative fact to what's being pushed out in these mainstream headlines, backed up with science. The expected is for the Atlantic to cool, and for this to drive much, much, much colder temperatures over to Europe this winter, to wipe out crops early, to damage the wheat harvest early, and also to send colder water under the sheet of ice in the Arctic, thereby creating more sea ice and allowing it to stay longer without melting. This is David Dilley's research. I encourage you to check out his research. That's David Dilley, D-I-L-L-Y. Sea surface temperature anomalies, here we go. North Atlantic, when I turn this up, I go, is that real? Basically, the entire Atlantic Ocean's blue except for one band that's probably, I don't know, looks about 1,000 miles wide, extending out from the eastern states, Maine, Vermont, etc., heading straight out of the Atlantic over to Spain. There's that one band that's warm, but everything above it and below it's cold, but not just cold. The North Atlantic is absolutely, it's showing like 3.6 degrees Celsius below the normal baseline temperatures from the 30-year average, 1981 to 2010. And just in the last 7 days, extreme ribbon of cold off of Newfoundland there in Canada. And you know, when they talked about in the 1700s, enormous fogs and wind events and hail events and the exact same stuff we're seeing today climatically, all these same stories that you're seeing in the news media again and again and again about extreme hail, 3 feet deep, bigger hail crashing, bashing through everything, including greenhouses and crops. We start to see the same thing repeated in historical accounts of sailors and different persons living in Europe at the time, specifically France. Now, for some reason, France seems to have one of the most pronounced effects in showing you what is happening with the climate. Like France seems to be well above everything else in Europe that's in terms of cooling and in terms of moisture, rain, except for Germany. France has taken a pounding. Now, you got to realize that the elevation in France going toward coastal is way, way lower than something like the Italian Alps, Swiss Alps. But they're getting record snow up there. I mean, just week and a half ago, they had all-time record snow. It was almost 3 feet of snow up there. That's the Italian Alps. Media didn't really cover on the all-time record snow. I mean, what about the floods through Greece right now? What about the floods through Austria right now? I mean, full cities just getting washed away up there, just streets turning into rivers. But that has something to do with colliding air masses between hot and cold. The droughts are the focus on the news. What about that extreme heat and cold smashing together to cause these massive floods? So there's a lot of really good weather maps out there, like Ryan Maue's site. He has a bunch up, and Joe Bastardi up on Twitter. You can follow these through global sea surface temperatures. Again, I want to go a little bit interactive with you. So when I talk about some of these events, you can take a look at the temperature data sets I'm looking at. So I'm going to take you over to nullschool.net. Now, if the first time you ever heard of this, let's jump in it together. I want it to be interactive so we can both enjoy the experience. So this is nullschool.net, nullschool.net. Now, all you want to do is just click on it. It's going to bring you over to the front page. It looks like it's a stick figure. And then there's one little entry below it. It says Earth Wind Map. That's where you want to click onto. You click on that, and it'll bring you to a full global map. It'll take just a second to render. And here we go. Now, the globe, you can spin it around. It's a fully interactive globe as well. Now, if you use your mouse cursor, you can zoom in and out on it. You can go forward and zoom in and out. Okay, so the first thing that they're going to bring you up to is going to be the wind patterns on there. So then you're going to find something that says Earth down in the bottom left corner. So if you click on that, it'll bring up all these different choices here. So we're going to kill two birds with one stone. I'm going to explain the polar vortex and the equatorial vortex, as well as we're going to take a look at temperatures across the northern hemisphere and see where it's cool and where it's warm. So you're going to see all these different choices down here. There's GFS, NCEP, we got the National Weather Service. Those are the different models that you can click on that will show you this information inside this interactive Earth view of wind and surface temperatures. They also have carbon dioxide. You can take a look at pollutants, ashfall or just pollution from factories. You get the whole different range of things to look at, let's say, within our atmosphere and what's happening. So all I'm going to do is come down to where it says height, and that's SFC. That's surface temperature at 2 meters or 6 feet above the ground. And then where it says overlay, it says wind and then temperature, relative humidity. So I'm going to go ahead and click on temperature here. And what it'll do is it'll bring up, and the color should change, but the wind will still stay there. The wind will be on the map. So you can see which direction the wind flows are going. And then all you have to do really to find the temperature is just click over the area you want to, and there'll be a green circle that will appear on the globe. And wherever you click, you can just keep clicking across. It will just change your location and then also put the temperature there for you. You can take different looks at it. If you put projection at the bottom, it will just change the way your globe appears. It'll make it flat or a circle, or just different ways to look at how you can render the information basically. What I also want to do is, if you're interactive with me, you're going to come to right down to where it says height, about the 6th entry down, it says height. And as you go through and you click these HPA, which is hectopascals, better known as millibars for those of you out there, you can jump up in height in the atmosphere. So when you're looking at 500 millibars, up around, 18,500 feet or so, 500 millibars. So mostly when you're looking at temperature charts, you're going to look at the 500 millibar chart. So that's hella up there. You know, we're looking a good 3 miles plus up in the atmosphere compared to ground surface temperatures. Now, what you're going to start to do is see jet stream flows beginning when we get up into this higher height, if you will. And when you get up into 250 millibars, the pressure decreases the higher you go up. So when we're thinking about reading these charts here, the higher you go, the lower the pressure, because it's not one full atmosphere anymore. You're way going up out of the atmosphere. So when we come way back down to the ground, you get the full atmospheric pressure. That's why when you go scuba diving, that water's even heavier and squeezes on you further. So then you're below and you're even getting more pressure because that water's heavier on top of you. So it works the same way in the atmosphere. At the very bottom ground level, we're at sea level, we're 6 feet above it, and that is really dense air pressure, like the densest you pretty much get on the planet, unless you maybe go into a deep valley like the Grand Canyon. The higher you go, the pressure releases. You know, that's why they have to pressurize the cabin of your airplane when you fly. 30,000 feet is right where we are at 250 millibars. 250, and then there's also 70 and 10. 10 is so far up, nobody ever uses that. It's all just the same circling winds around the planet. So what we want to do is jump between 250 millibars and 70 millibars. And this will give you a great indication. And you want to click on back to the wind, and the temperature should change, and you probably have some like oranges and greens, and you will see how the wind flows are moving at these different heights in the atmosphere. You have to realize that these heights are the ones that are driving the climate and driving the cloud patterns and driving all of the cloud bands, and the jet streams are what we're looking at up at these heights in our atmosphere. So I'm going to focus on 250. So just, if you're with me, go to the height, click on mode, which is air, and then click on the overlay, which is wind, and then set at 250 millibars. So those three all right in a row there. Just under control, it'll say mode, height, and overlay. Mode will be air. Height will be 250 HPA or 250 millibars. And then the overlay is the wind. And you're going to get all these reds and different colors, greens and reds, moving all across. It looks like a bunch of worms cruising across the planet.